Hello everyone. Today we are going to solve 238 product of array except self from Leetcode. So let's see how frequently it's been asked. It's as you can see, it's frequently asked at all major companies. And let's start the timer. Okay. So given an integer array nums, return an array answer such that given an integer array nums, okay, return an array answer such that answer I is equal to the product of all the elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operation. So except self, yeah, it's so we have given an array, as you can see, 1 2 3 4, and here we are multiplying this with all the numbers except itself. So the brute force would be to simply have two for loops run, and I guess it will time out if we do this way. Brute force is having two for loop run. That would be the simple brute force that we can think of. G++ and have a let result array and return result if I is not equal to j, then only and let multiply is equal to nums of I. We'll keep it as nums of I, and then we'll multiply star into nums of j, and once we are done multiplying everything, we'll push this multiply multiple sorry multiply to this answer and then finally return this. So if we run this, wait, what? So for every iteration, multiply should change, right? Why the output is coming out to be 24? Console.log, let's check. Is it something related to JavaScript? Okay, yeah. So 1, 2, 3, 4. And in the end, what am I returning? Console.log answer Okay, except itself. Okay, gotcha. So you don't have to multiply with itself. Other than that, we can do it. Now it's right. Sorry, my bad. Yeah, if I submit this, I guess it will time out because of the double for loop that we are having, and it it did pass, but as you can see, it took a lot of time, um, which was not that efficient. O of n square, the time complexity was, and O of 1 was the space of 1, or O of 1 was the space complexity if we are not considering the result. If we are considering the result, then O of n. Okay, so once, so how can we optimize this is the question, in and reduce, like, from 2 for loops to 1 for loop. How can we do that? Can we, without division operator, right? Yeah. Okay. So in the end, we just have to multiply everything, right? What if we take 2 pointers? It's a bit tricky. Pointer left and pointer right, and okay, we must write an algorithm that runs in O of n time complexity. As I've solved this question, I'm able to recall, like, what we can do about the solution. Like, it's a bit tricky if you are planning to do it in just one loop. But if you think, like, we can have a left multiple and a right multiple, if I can think clearly what it was. Um, but how can I keep left multiple? Okay, let's see. It's been almost 9 minutes.
Hello everyone, welcome to this Leetcode video solution. In this video, I'm going to solve the Leetcode problem product of array except self. Suppose we have an integer array like this. For each element, we need to calculate the product of all the elements except this element itself. We will return the array made by the resulting product of each element, and we're going to call it the answer array. Suppose we need to calculate the self-except product for A2. We can first calculate the product of all the elements, then take the product and divide it by A2. The result of this division will be stored in the answer array at index 2. However, based on the problem description, division operation is not allowed to solve this particular problem. Besides, it won't work if A2 is 0, and we'll get a divided by 0 exception.
Yeah.
Now that division is not an option, it seems that we need to use brute force to solve this problem. Let's take A2 for example. We could traverse the array and calculate the product of all the elements except A2. And for other elements such as A3, we also need to do the same thing, except this time A3 will be taken out instead of A2. If we follow this route, we'll have to traverse the array over and over again to calculate the result for each element. That will take a lot of time, approximately O(n) squared, assuming n is the length of the input array. To further simplify this procedure, let's take a closer look at the result for element A3. You'll soon notice that the product of array except A3 can be divided into two parts, left and right. The left part is a prefix product up until A3, and the right part is the suffix product up until A3. Therefore, we can use two arrays to store the prefix product and suffix product separately, then calculate the final result by multiplying these two parts. Both the prefix product and the suffix product can be obtained by traversing the input array once. That is, we can traverse the input array from left to right to calculate the prefix product, and traverse from right to left to calculate the suffix product. Now let's look at a simple example. Given an integer array, we start when traversing it forward, from left to right, to obtain the prefix product of each element. For the leftmost element 4, the prefix product of it can be considered as 1, as any number times 1 will still be itself. For the second element 5, we take the previous prefix product, which is 1, times the number at the previous index, which is 4. Then we'll get 4 as the latest prefix product. For the next element 1, we take the previous prefix product, which is 4, times the number at the previous index, which is 5. Now we get 20 as the latest prefix product. Similarly, we can calculate the prefix product for all other elements. Then, after obtaining the prefix product of all the elements, we need to traverse the integer array backward, from right to left, to obtain the suffix product. We begin at the rightmost element 6. The suffix product of it can be considered as 1 due to the similar reason. Then we move left to element 10. We take the previous suffix product, which is 1, times the number at the previous index, which is 6. Then we get 6 as the latest suffix product. Similarly, we keep traversing backward to obtain the suffix product for the rest. Now we have obtained the prefix and the suffix product of each element by traversing the input array twice. Then we will declare an answer array, traverse and multiply the prefix and the suffix product to obtain the final result, and it will store the result into the answer array. Now let's analyze the time and the space complexity for this approach. Suppose the
Okay,
length of the input.
so yeah, that's what the solution looks like. It's not that intuitive if you see. Yeah, it's not that intuitive, but um, you know, we can try this out. Okay, so let left is equal to left product would be new array and it would be nums dot length. Okay, and it would be empty right now. New array nums dot length and left of c0 equals to 1 and right of nums dot length minus 1 equals to 0 as shown in this, and let I is equal to 1, I is less than nums dot length I plus plus. What we have to do is we have to left of I would be equal to nums of I minus 1 into left of I minus 1, right? 4, like 1 into 4 is 4, then 4, then for 20, 4 into 5 is 20, then for this guy 20 into 1 is 20. So, and then for let j is equal to 0, j is equal to nums dot length minus 2 I equal to 0, while I is greater than equal to 0, we have to do this, and then I minus minus right of I, right of I is equal to nums of I plus 1 into nums into right of I plus 1, and then finally what we can do is for let I is equal to 0, I is less than nums dot length I plus plus nums of I into, so phi is equal to left of I into right of I, and return nums of I nums. Or we can do just ans dot push ans. Okay, why is it coming out to be 0? Oh, 1. Okay, okay, yeah. This is not that intuitive, but you know what? Like, yeah. So why don't we do one thing? What we can do is just to get the idea completely, um, product product of array except self. I'm just noting down this array. We have 4, 5, 1, 8, 2, 10, 6. Right? You can go here. Just refreshing this page so that we can see our white blackboard. Oh dear. Okay, how can I refresh this guy? Because I'm not able to see anything. Okay, yeah, I'm able to see this. Let me go here, rub this off. Yeah, we have array. And what was the array? Oh, 4, 5, 1, 8, 2, 10, 6. Okay, so what we are doing here is taking the multiplication in this. Okay, so left, we have a left, and then what we are doing is keeping this 1 as you are not counting it, then 1 into 4, calculating this, 1 into 4 is 4. We are starting the loop from here, this I, and we are also taking this. So we are always taking the multiplication of these two. 1 and 2 for this, and then for this position we have to take multiplication of 4 5s. So now we have to take multiplication of this. So this will come out to be 20. Then we have to take multiplication of this for this guy, which will come out to be 20. Then we have to take multiplication of this guy for this, which will come out to be 160. We have to take multiplication of this guy, which will come out to be 0, 2, 320. Then you get the idea, right? You have to take. So we are just uh, referring to the previous element, and then like previous element and taking out the uh, like it starts from the first. We are not considering this first and just taking on the left side. Keep on taking the left side, like at this position. So let me start this. So you have this array 0, 1, 2, 3, 4, 5, 6. At 0th position, if we start from left side, what should be the value if we want to skip this 4? It should be 1, right? Because there is nothing on this side. So for 5, what should be the left side multiplication? It should be 1 into 4, right? For the second position, what should be the multiplication of these two, right? So 4 into 5, we have already 4 here, so 5. Sorry, 20. My bad. 20, and then for the third position, we should be having multiplication of this. So we till this point we have already multiplied it. So we just multiply with this thing. So that's why. So we'll get 160. For fourth position, we'll multiply 160 with 8. So that's how we'll get all of this filled. And similarly, for the right side, we consider right multiplication to be 1, and then we multiply, um, filling up the gaps from this. And yeah, it's very clever way of finding, like multiplying the array with itself. Sorry,
Hey everyone, welcome back, and let's
I played a video by
write some
mistake.
more neat code today. We're given an n by n matrix.
Okay, so yeah, it's pretty cool. So this reduces our time complexity from O of n and space complexity to O of n as well. Because yeah, 2n, actually 2n, but we turn it down to n. As you can see, the space complexity would be O of n. Yeah, there is also O of 1 approach. So what this guy is doing is it's keeping the left answer in this, and r is equal to 1, then answer of I into r into nums of I Okay, sorry, I was just reading through the comments. But yeah, this is quite popular question. Of n square. Cool. Did we submit this already? Yeah. We did. Okay, cool. And okay, that's all for